Hello friends, welcome to Learner's Planet. Friends, in this session we are going to discuss mathematical induction. That is precisely the chapter is in grade 11, principle of mathematical induction. So we are going to discuss the same. It is generally not a part of competitive exams, but yes, if you are appearing for board exams, the questions from this topic are frequently asked. Okay, so let's begin this session. First of all, let's discuss what is exactly a principle of mathematical induction, right? Suppose you are given a mathematical statement, right? So if Pn, right? Pn is a statement that is involving a natural number n, right? Suppose you can take maybe Pn is equal to 1 plus 2 plus 3 till n, right? That is n plus 1 by 2. That is sum of first n natural numbers is n plus by 2. So that's a mathematical statement. Now with the use of or with the principle of mathematical induction, we need to establish this, right? So what are the steps that you need to follow? Just listen to me carefully. First of all, what you have to do, you have to see whether it is true for P1 or not. Okay. So the first step is P1 is true or not. So how would you do that? You put up the value of n as 1, right? Pn, n is 1. So here if I put n is equal to 1, I'll be getting 1 into 2 by 2, that's 1, right? So P1 is equal to 1. That means Pn is true for n is equal to 1, right? And next, we have to establish that Pm plus 1 is true whenever Pn is true or Pm is true. Okay. That means whenever Pm is true, Pm plus 1 is true, right? Then Pn is true for all natural numbers n. Okay, so these are the 2-3 steps that you have to follow. Otherwise the chapter is a theoretical chapter. Just do all the sums 2 to 3 times and it's really easy. Okay, because the weightage is around 8 to 10 marks given to this chapter. Okay, so if you are clear, like if you are clear with the steps, you'll be able to get all these marks. Okay, so let's begin to take the first question. Now let's take the first question. We have just discussed 1 plus 2 plus 3 till n is n plus 1 by 2. That is the sum of first n natural numbers is this, right? So the steps to be followed, just see carefully. Let Pn is equal to 1 plus 2 plus 3 till n is equal to n plus 1 by 2, right? So this is the statement that's given to us. First of all, let's find out P1. So P1 is equal to 1, right? So it is true for n is equal to 1. Now the second step, let Pm be true, right? So if Pm be true, that means 1 plus 2 plus 3 till m will be m plus 1 by 2, right? So if Pm is true, 1 plus 2 till 3 till m will be m plus 1 by 2. Now we have to see whether it is whether Pm plus 1 is true or not, right? Pm plus 1. Okay, so what Pm plus 1 will be? 1 plus 2 plus 3 plus m plus 1. That's actually Pm plus 1. Okay, so Now 1 plus 2 plus 3 till m, it's m plus 1 by 2, that we can take it from here, m plus 1 by 2, right? So since we have already assumed that Pm is true, so 1 plus 2 plus 3 till m is m plus 1 by 2. Okay, so 1 plus 2 plus 3 till m, I just write m plus 1 by 2. Then we have m plus 1. That's actually Pm plus 1. Okay, so I can take m plus 1 as common, then I'll be left with m by 2 plus 1. So that is m plus 1, m plus 2 by 2, right? Now that means Pm plus 1 is true. How Pm plus 1 is true? If in this equation, or in this equation, if you put n is equal to m plus 1, you will be getting this, m plus 1 into m plus 2 by 2, right? So what you have to write, Pm plus 1 is true, right? That means Pm is true and Pm plus 1 is true. Okay, so hence by the principle of mathematical induction, the given result is true for all n belongs to n, right? Since I have already told you this is a theoretical topic, so you just have to be careful while writing down the steps. The marks of steps are there, right? So I just write it down. By the principle of mathematical induction, Pm plus 1 is true whenever Pm is true. Okay, just go for a quick recap so you'll be able to understand it faster. Pn that is given to us, that's n plus 1 by 2, right? P1 is true, right? First of all, this is the first step. Then we assume that Pm is true. If Pm is true, that means if I put n is equal to m, I'll be getting this. So this is the assumption, let Pm be true. That is the first step, right? Then we find out Pm plus 1. So Pm plus 1 will be what? Here the sequence is going up to m. In case of Pm plus 1, the sequence will go up to m plus 1, right? So I just add m plus 1 over here. Now we have assumed this to be correct. So 1 plus 2 plus 3 till m I can write down as m plus 1 by 2. So I write down m plus 1 by 2 over here. Then we are left with m plus 1. Okay, so I take LCM. So finally I'll be getting this. So Pm plus 1 is this. That we have got by this method, right? Now if I put m plus 1 over here, what I'll be getting? M plus 1, m plus 2 by 2, right? So that is the already given mathematical statement, right? So Pm plus 1 is true whenever Pm is true, right? So whenever Pm is true, Pm plus 1 is true. That's why by the principle of mathematical induction, Pm plus 1 is true whenever Pm is true. That you have to write. Okay, so this way you have to prove this. Let's take the next one. Now see this, 1 square plus 2 square, that is sum of squares of first n natural number is n plus 1, 2n plus 1 by 6, right? So first of all, let Pn be the statement. So Pn is equal to 1 square plus 2 square till n square is equal to 1 upon 6 n plus 1, 2n plus 1, right? So the first step, P1 is equal to 1 upon 6 into 1 into 2 into 2 plus 1, that's 3. So 6 by 6, that's 1. So P1 is true. Now the next step, let Pm be true. All questions will follow the same steps. Let Pm be true. So if Pm be true, then 1 square plus 2 square till m square will be m plus 1, 2m plus 1 by 6. Okay, so that's first equation I assume. Now next is we have to write down Pm plus 1. So Pm plus 1, we have to show that Pm plus 1 is true, right? So when we have to show Pm plus 1 is true, that means we have to show 1 square plus 2 square m square plus m plus 1 whole square should be equal to, instead of m we need to put m plus 1. Instead of m we have to put m plus 1, so it will be 2m plus 1 plus 1. So that is okay, that we have to prove. Now what? 1 square plus 2 square plus 3 square m square plus m plus 1 square, right? Now this is actually Pm plus 1. So 1 square plus 2 square up to m square, we know that it is m plus 1 to m plus 1 by 6, right? So I just write it over here, m plus 1 to m plus 1 by 6. Then we are left with m plus 1 whole square. Okay. Then what we have to do? We can take m plus 1 as common, and we are left with m into 2m plus 1. I can take LCM, 2m square multiply, 2m square plus m, then plus here m plus 1 I have already taken common, so we are left with just m plus 1, but we have to take LCM also, so it will be 6m plus 6, okay, divided by 6. M plus 1 by 6. Here it is 2m square plus 7m plus 6, right? So we can factor 6 into 2, 12, so 4 and 3 can be factors. So 2m square plus 4m plus 3m plus 6. So that is m plus 1 by 6, 2m common, m plus 2 plus 3 common, m plus 2, right? So it will be m plus 1 by 6, then it is 2m plus 3, first of all m plus 2, then 2m plus 3, right? On solving this we are getting this. Okay, now this can be written as m plus 1, m plus 2, 2 m plus 1 plus 1 by 6, right? So here you just can match here m plus 1, m plus 2, 2 m plus 1 plus 1. Okay, that we had to prove, and that we have proved. Okay, so Pm plus 1 is true. Okay, so Pm plus 1 is true whenever Pm is true. Okay, so hence by the principle of mathematical induction, the given result is true for all n belongs to n. You have to write down the statement always. Hence by the principle of mathematical induction, Pm plus 1 is true whenever Pm is true, or we can say the given result is true for all n belongs to n. Okay, so these are the standard steps of all the problems. Okay, let's take the next one. This question, Pn is equal to 1 upon 3 into 7 plus 1 upon 7 into 11, 4n minus 1, 4n plus 3 is equal to n upon 3, 4n plus 3, right? Now step 1, P1 is equal to, put 1 upon 3 into 4 plus 3, that is 7. So it's 1 upon 21. So P1 is true. Okay, 1 upon 3 into 7 we are getting the first term. So P1 is true. Second step, let Pm be true. Okay, so Pm is true. That means we have to write Pm is equal to 1 upon 3 into 7, 1 upon 4m minus 1, 4m plus 3 is equal to m upon 3 4m plus 3. Okay, now we have to prove that pm plus 1 is true. Now what is pm plus 1? 1 upon 3 into 7 plus 1 upon 7 into 11 till 1 upon, instead of m I'll be putting m plus 1 over here, right? So what it will be, 4 m plus 1 minus 1 into 4 m plus 1 plus 3 is equal to m plus 1 upon 3 4 m plus 1 plus 3. That we have to prove. Okay, now what? We write down pm plus 1. So 1 upon 3 into 7 plus 1 upon 7 into 11 till 1 upon 4 m minus 1 4 m plus 3. That's up to mth term. Then the next term will be 1 upon 4. Here m, instead of m I'll be putting m plus 1, so it will be just rough work, 4m plus 4 minus 1. So that is 4m plus 3 into, instead of m I'll be putting m plus 1, so here it is 4m plus 4 plus 3, so it is 4m plus 7. Right? So that is actually pm plus 1. Now up to here we know the answer, right? 1 upon 3 into 7, 1 upon 7 into 11, up to here it is m upon 3 times 4m plus 3, right? So m upon 3 4m plus 3, 3 times 4m plus 3. Now we are left with this, so 1 upon 4m plus 3 into 4m plus 7, right? That is pm plus 1. Now once again we take LCM, so that is 1 upon 4m plus 3 can be taken as common, then it is m by 3 plus 1 upon 4m plus 7. Okay, so it is 1 upon 4m plus 3, then here it is 4m square plus 7m, and it is 3. Okay, and this is 3 4m plus 7, right? Again we can factorize 7. 7 can be broken up into 2, 4m and 3m. So here it is 4m plus 3, 3, 4m plus 7. Then here it is 4m plus 3m. So 4m I take common, then it is 4m, m plus 1 plus 3 m plus 1. Okay, so it is 4m plus 3 m plus 1 upon 4m plus 3 into 3 into 4m plus 7. So 4m plus 3, 4m plus 3 is cancelled, so we are getting m plus 1 upon 3 times 4m plus 7, right? What we had to prove, I have written over here, m plus 1 upon 3 times 4m plus 7. This is actually 3 times 4m plus 7. That we had to prove, and that we have proved, right? So what will be the next statement? Pm plus 1 is true. Okay, so Pm plus 1 is true whenever Pm is true. So you have to write down, hence by the principle of mathematical induction, the given statement is true for all n belongs to n. That's the standard line you have to write. So all the steps are standard. Okay, no need to worry, you just have to solve all the sums for 1 or 2 times. After that, all the marks for the principle of mathematical induction will be free for you. Okay, let's take the next one. Now, good number of questions based on the previous pattern you can do. Now this is a new pattern, the next pattern. Here you have to prove that 5 raised to 2n minus 1 is divisible by 24 for all n belongs to n, right? Steps are once again same. Similar, I mean to say, whatever the changes are there, please just see carefully. The first step is Pn is equal to 5 raised to 2n minus 1, right, is divisible by 24. Okay, that is the statement. Now the first step, P1 is equal to 5 square, that is 25 minus 1, that is 24. Okay, so 24 is divisible by 24, so P1 is true. Okay, next step, the same, let PM be true. So PM is equal to 5 raised to 2m minus 1, right? So it is divisible by 24. That means 5 raised to 2m minus 1 is divisible by 24, right? That we are assuming. That means what? 5 raised to 2m minus 1. If it is divisible by 24, that means 24 into any constant, I can assume it to be k, right? That means 5 raised to 2m minus 1 is multiple of 24. 24 k times is 5 raised to 2m minus 1. We don't know the value of k because it depends upon m. So we just assume that PM is true. That means 5 raised to 2m minus 1 is multiple of 24. So 24 times k is 5 raised to 2m minus 1, right? Now we have to show that PM plus 1 is true. Prove PM plus 1 is true. For that we have to show that 5 raised to 2m plus 1 minus 1 is divisible by 24. Okay, that we have to prove. So I just write down PM plus 1 is equal to 5 raised to 2m plus 1 minus 1. Okay, we can expand it. 5 raised to 2m plus 2 minus 1. So this is 5 raised to 2m into 5 square minus 1. Now see, here we are having 5 raised to 2m into 5 square minus 1. This statement can be written as like this. Okay, now instead of 5 raised to 2m, I can write down 24k plus 1, right? 5 raised to 2m minus 1 is 24k, that we have assumed. So 5 raised to 2m will be 24k plus 1. So I just write down it over here, 24k plus 1 into this is 25 and this is minus 1. Okay, now just open it up. 25 into 24k plus 25 minus 1. Okay, so that is 25 into 24k plus 24. So 24 can be taken as common. So here it is 25k plus 1. That means this number is multiple of 24, right? If it is multiple of 24, it will be definitely divisible by 24. Okay, so we have proved that PM plus 1 is true, right? That means this expression is divisible by 24. So whenever PM is true, PM plus 1 is true. Hence by principle of mathematical induction, it is true for all n belongs to n. Standard statements are there. Okay, so I hope you are getting it. I just do 1 or 2 more sums on this pattern, so it will be set in your mind. Now see this problem. 5 raised to 2n plus 2 minus 24n minus 25 is divisible by 576 for all n belongs to n, right? So Pn is equal to 5 raised to 2n plus 2 minus 24n minus 25 is divisible by 576 for all n belongs to n, right? So first step, P1 is 5 raised to, instead of n if I put 1, it will be 5 raised to 4 minus 24 minus 25. So it is 625 minus 24 minus 25. So that is 576. So P1 is true. Okay. Now next is let PM be true. So PM is equal to 5 raised to 2m plus 2 minus 24m minus 25, right? So this is PM, it is true. That means this expression is divisible by 576. So this expression can be written as 576k. Okay, the same way we have done the earlier problem, the previous problem. So 5 raised to 2m plus 2 minus 24m minus 25 is 576k. Okay, now we have to prove that Pm plus 1 is true. So let's see. Pm plus 1 is equal to 5 raised to 2 m plus 1 plus 2 minus 24 m plus 1 minus 25. Okay, we simplify this. It is 5 raised to 2m plus 2. So precisely it is 2m plus 4 minus 24 m minus 24 minus 25, right? Minus 24m minus 24 minus 25. Okay. Now once again similar steps we have to follow. It's 5 raised to 2m into 5 raised to 4 minus 24m minus 49. Okay. Now from here we have to find out the value of 5 raised to 2m. So 5 raised to 2m into 5 raised to 2, that is 25 minus 24m minus 25 is equal to 576k. Okay, so 5 raised to 2m will be 576k plus 24m plus 25 divided by 25. Okay, so I just write it over here. 5 raised to 2m is equal to 576k plus 24m plus 25 divided by 25. 5 square. That is a value of 5 raised to 2m. Then we are having 5 raised to 4. Okay. Then minus 24m minus 49. Okay. So this square is cancelled. So we are left with 5 square over here. Okay. So just see this. 576k into 25 plus 24 into 25m plus 25 into 25 minus 24m minus 49. Okay, this statement is converted to the statement. Now this is 576k into 25 plus, here it is 24 into 25, that is 600m minus 24m. So 600 minus 24 is 576. So it is 576m. Okay, then 25 into 25 is 625. 625 minus 49 is 576. Okay, so 576 can be taken as common, then we are left with 25k plus m plus 1. So it can be, you can assume this to be any new number. So 576x. precisely we have to show that it is multiple of 576. That means Pm plus 1 is also this Pm plus 1 is also true whenever Pm is true. Again the same statement you have to write down, when Pm plus 1 is true whenever Pm is true. Hence by the principle of mathematical induction it is true for all n belongs to n. Okay, so we'll be taking more problems on mathematical induction in our next session. Bye bye.